Hello, well, today's little waffle, you keep asking for waffles, so I'll carry on. It's about electricity. When I was more active in ham radio than I am today, it's changed somewhat, I'm afraid, but we used to have construction nights. People would take various receivers and transmitters for others to see what they'd built. And just to do something different, I took a few bits and pieces to instruct the beginners on a few principles, and this seemed to go down quite well. And I've recently dug out some bits and bobs, and for those who can recognise what they see in front, this is Jacob's ladder. It's the usual sort of thing you see in science fiction films, Dracula's castle and all this sort of thing, because it looks impressive. But basically what it is a wooden box, and inside the wooden box is a oil heater ignition transformer, AC transformer, and the output is fed to the vertical rods. And if I switch it on, you'll see that you can see why it's called Jacob's ladder, as you have runs going up the ladder. Sometimes you can have many of them, but in this particular case, hasn't warmed up yet. We've just got the one. So what's happening here? Why does this arc travel to the top? Let's turn it off for a moment, as I don't want to reach my maker just yet. Why does it travel to the top? You would think the obvious answer would be that it would take the shortest path, or to be correct, the least line of resistance, which is the narrowest point, which is what happens when I first switch on. But this arc heats up the air, and warm air tends to rise, but this is not what's causing the arc to travel to the top. At the same time as heating up the air, it ionises the air around the arc, and ionised air is more conductive than non-ionised air. So although further up the gap, you would think there'd be more resistance, the mere fact that the arc moves to it proves that there is not. This sometimes explains why perhaps a bungalow or a low building would be struck by lightning, and perhaps a church with a spire next door is untouched. Well, the church with the spire may be unoccupied and cold, whereas the bungalow may have a fire on, hot air going up, carbon particles, ionised particles, which may extend up way beyond the spire of the church. A quick amusing little story. I worked for a radio firm, did an apprenticeship as a radio engineer. We went out to a lady who'd been struck by lightning, or a house should I say, and it was in the early days of Band 1 TV reception, big H aerials on the roof, and she was sitting in a chair in the living room. Almighty bang, and the house was struck, the aerial obliterated, the chimney stack split in half, and the lightning travelled down the coax cable into the house. The coax cable had been papered over, and the paper just blew open with a brown stain down the wall, right to where the lady was sitting, travelled straight down to within about 18 inches of her head, and then turned 90 degrees, went through the wall to a water pipe the other side. Now how's that for being lucky? To say she was a bit shaken is an understatement, but I bet it cured her hiccups. Okay, well we'll move on from sparks, but still on the theme of electricity, electromagnets and so forth. I'm sure you've all done the playing around at physics. If you did physics at school, I wasn't so lucky, but you played with coils and magnets and the usual stuff Faraday does, I'm sure you know. Anyway, you might find this a slight variation, and could be the basis for a little trick here. Anyway, we have a nice big coil, as you can see, and which I've connected to the mains, and AC mains is producing a magnetic field, around and through the coil, and if I switch on and place something iron within the coil, I can feel it buzz, and it's inducing currents into the bolt, and the bolt is magnetic, but it's only magnetic while the current is flowing. Now here we have a piece of 1/2 inch copper pipe which will sit over the top of the magnet, but as you can see it doesn't want to go in, it's repelled. So what's happening here? Why won't this go in? If I switch off, it'll drop. So what's happening? Why is this being repelled? Well, believe it or not, this piece of copper pipe is a winding, albeit only one turn, but it's a short-circuited one-turn winding. So it is receiving EMF from the magnetic field in this coil, inducing currents to flow around this piece of pipe, and because currents flow, it will have an associated magnetic field, and this field is in phase with the field that's currently here. So two like fields repel one another, which is why the piece of copper tries to get away. Okay, let's switch on again. Here we have a piece of aluminium too. Exactly the same. Doesn't want to go in there. Oh, it's fell out. Let's stop, switch off. It fell through the bottom. Never mind. I will prove the point. This is not an outtake, folks. This is as it's happening. Right. It's still repulsed. You can see that. Okay, let's put that in the middle. See, here we have another piece of pipe. And it's switched on. So what happened there? Why isn't it rejected? Well, I'll switch off. And I've cheated. What I've done here, I've done a saw cut the whole length of the copper pipe. Now currents cannot travel around the copper, and if there's no current travelling round, there's no magnetic field to be opposed. Let's drop that one on, which has no effect because it has a cut in. Let's drop that one on top. Now let's switch on. I'll stand back. It's quite impressive. We could have a little cannon there, couldn't we? Anyway, just a little bit of an amusement. As I say, this was originally constructed to get the attention of a few would-be radio hams. Let's see if I can dig out some more bits and bobs.